So firstly, we need to drop a bottle cap from the first bowl or plastic bowl. You can see that it floats on top. The water level only rises a little, because the light object displaces a small amount of water because it doesn't sink deep. The buoyant force pushing it upward equals its weight, so it stays floating. Next, I'll use this tomato as my next experiment. Okay, so did you notice any difference? When I place it in the water, it partly sinks and partly floats. It doesn't go all the way down. The ruler shows the water level rises more than with the light object, because the tomato is denser than a plastic cap, so it needs to displace more water to balance its weight. The buoyant force increases as more water is displaced, keeping it halfway afloat. Okay, so we're gonna put the last experiment. Let's observe it closely. When I drop it, it sinks completely to the bottom and the ruler shows the highest water level among all. Because this is much heavier than water, so even though it displaces the most water, the buoyant force isn't strong enough to hold it up, causing it to sink. In every case, the object caused the water to rise because it displaced some of it. The heavier the object, the more water it displaces. This proves Archimedes' principle, which states that the buoyant force on an object is equal to the weight of the fluid it displaces. In this part, I'm just looking at the height differences out of curiosity. And that's my experiment on Archimedes' principle, together with the lesson it can teach us in life. Thank you for watching. Yes, sir.